Okay, this is a lesson for Math 1314. We are going to learn Section 1.1 graph. So the graph in here we are going to talk about is the graph, we are going to plot it in the rectangular coordinate, or sometimes we call the Cartesian coordinate. So in the rectangular coordinate, we have two axes. One is called x-axis with the horizontal one. So this is the x-axis, this horizontal line. And the vertical line is y-axis. So of course they are intersecting at a right angle. So this is y-axis. And the intersection point, this point we call that is origin, which is the point is a 0 for y and also is a 0 for x. So for the coordinate, you can see that for x, we define everything on the right hand side of x, that is positive number. And everything on the left hand side of x, those are negative number. So in here, I'm just going to mark those integer 1, 2, 3, 4, -1, -2, -3, -4, just like the number lines. And you can see that those are the distance from the origin, right? So 1 unit from origin, 1 unit from origin, but one is left, one is right. And for y-axis above the 0, those are positive, and below the 0 and negative. So to represent, for instance, a point on the xy or rectangular coordinate, we use order pair. Okay, so it's a pair of number and they are in order. So the first one is indicated x, which is the distance from 0 to that point horizontally. Second one is y, which is the vertical distance from 0. Okay. So the one I just labeled in here, you can see is 3 units from the 0 and 2 units from the 0 vertically. So indicate this point is 3, 2. So this is an order pair, which is very important. If I wanted to say 2, 3, where's the 2, 3? Well, 2, that would be 2 from the origin horizontally, and 3 will be from 0 vertically. So that is 2, 3. So they are completely different points. So the order is very important. As an exercise, we are going to plot a point. So we are going to plot, let's say, -1 and 3/2. So -1, you can see x is a negative, will be on the left hand side. So -1 vertically is 3/2. So 1, well, 3/2 is between 1 and 2, halfway in that. So this is the point as -1, 3/2. So I hope that you can now you have some idea how to plot the points on the coordinate plane. But the next step is we are going to graph equations. So how we can graph equation in two variables. Okay. So in this case, I'm just going to use x and y because in the axis we label x and y. In the application problem, sometimes you can see a horizontal or vertical axis might not be x or y, might be the other variables. That will be okay. So when we graph an equation in two variables, basically you are going to graph some of the points, satisfy the equation because they are the solution of this equation, and then connect those points. Speaking solution of an equation, let's take a look. What is solution of an equation? I'm already written in here to save some time. You might want to take a look. An equation, a solution of an equation in two variables, x and y. Okay, so here I'm emphasizing two variables because when it is three variables, that you need to graph in space. It's an ordered pair of real numbers with the following properties. When x coordinate is substituted for x and y coordinate is substituted for y in the equation, we obtain true statement, which is just like what I said. If you plug the both order pair into the equation should be true. If it is true, that is a solution, but if it's not true, that is not a solution. Okay. So let's take a look of an example. For this example, we are going to graph this equation. Y equals 4 minus x. Some of you are still remember from algebra class, then you will know that this is a linear equation with slope is -1, y-intercepts 4. You can use that idea to graph that equation. But in this lesson, we are going to use the point plotting method. So as a name, we need to find some points. Okay. So basically, my suggestion is find at least 3 or 4 points, so you have some general idea. This is just subtraction in the operation, so basically you can use any real number. Well, of course, sometimes we want to use some number easier to calculate. So in this example, I'm just going to select some integer. I'm going to select a little bit more integer, just review how to evaluate the equation. For instance, I'm going to select x and then find the y. Okay, I like this table because I can see my ordered pair, okay, in here. So when I plot the points, it's easier for me to plot the point. I call that t table. So I'm going to select the x equal -3. -2, -1, 0, 1, 2, 3. I'm just thinking about the way on the x-axis. Okay, you can find some decimal or fraction as a practice, but in graphing we prefer the integers. So if x equals -3, substitute into these equations. 4 minus -3, that's 7. Okay, x equals -2, substitute the x in here, y will be 6. X equals -1, substitute in here, so that will be 5. And this is 4, and 3, 2, 1. So all those are points. Okay, in here I got the 7 points. So we will graph these equations with two variables. So the two variables are x and y, so we need to have our coordinate play in here, x, y. And let me just label some x value and y value. I'm just going to use the line. So you can see it's very important to label the unit in here. Okay. So the first point is -3.7. So -3.7 is about right here. 6 is -2. -1 corresponding to 5. And you can plot all those points, and 0 is 4, and so on. Okay, so to save time, just going to skip some of the points. I'm going to connect the line in here. So that's the line we are looking for. Right, so for in this line, there are some special points I want to point it out. For instance, this point. You can see this point is the graph intersecting on y-axis, so we call that as y-intercept. So in the y-intercept, of course, it's on y-axis. On y-axis, all the x value, because this is the origin, right? All the x values must be equal to 0. Okay, for instance, this point, we can see that from the order pair 0, 4. Okay? Alright, so in this case, the y-intercept is 4. Another point I want to point out is this one. And use similar idea to prove that this is what x-intercept, because it's intersecting at x-axis. Okay. On x-axis, you can see that all the y value must be equal to 0, so sometimes the x-axis can be represented by this equation y equals 0. Okay, so this x-axis is equal to, if I graph that correctly, should be 4 as well. Okay, the x-axis, you can see that that point, if we wanted to represent the point in here, is 4, 0. Okay, so those are the some of the special points on the graph, which is in the future we are going to learn how to find the x and y intercept. Let's take a look at another example for graphing. Okay, but I'm going to graph y equals absolute value of x plus 1. As the last example, we are going to find some points to help us to graph these functions. And I'm still using the t-table, and I'm still going to give x some value and find the corresponding y value, and hopefully I can plot some points over there. X, y, okay. So I'm going to still get those points, -3, -2, -1, 0, 1, 2, 3. Okay. So when x equals -3, put it in here, -3 plus 1, that's -2. But we need to take the absolute value. Don't forget that. That is 2. Okay, so x equals -2 plug into here. -2 plus 1 is -1. Absolute value is 1. -1 plus 1, that's 0. Absolute value of 0, still 0. 0 plus 1, that's 1. 1 plus 1, that's 2. 2 plus 1, 3. Absolute value of a positive number is the number itself. 3 plus 1, that's 4. Okay, again, those are the order pairs we are looking for, so we can use those points to plot the graph on the xy coordinate. As a last example, you might notice that I just used several points and then connected those points, right? So the graph is not broken, which is we call that is continuous function or continuous graph. The reason I can do that is the domain of x is all the real number, which means x can be used any real number for that operation. Sometimes x cannot. But in this case, yes, when we take absolute value, yeah, we can take absolute value of any real numbers. Alright, so we are going to plot this graph onto the xy coordinate plane. And personally, I like to use ruler to graph that instead of using the graphing paper. In this case, I can practice how to graph more accurate, especially if you are planning to be an engineer. So that's kind of sense or unit sense or number sense you want to be developed along the way learning math. So I'm going to have those numbers -1, -2, -3, 1, 2, 3, 4. And looking at my graph, well, the maximum so far I got is 4. I guess I have enough space for 4. So I'm just going to use those as 1, 2, 3, 4. Alright, the first point, -3, -2. -3, -2. So we'll be right here. Second one is -2, 1. -1, 0. So from the last example, you might notice this is our x-intercept, right? And 0 that's corresponding to 1, and 1 corresponding to 2, and 2 is 3, and 3 is 4, right here. Right, I'm going to connect those points, and you can see it's a V shape. So those are the absolute value functions look like, just maybe position a little bit different. Okay, as I mentioned, this is your x-intercept, and this is one is y-intercept. Y-intercept in this case is located at 1, x-intercept is located at -1. Speaking of x and y-intercept, I'm just going to do another graph on the screen. We are going to take a look what are the x and y-intercept in here. Let's just run the graph in here. Okay, so this is graph 2. Let me label some of the points. So maybe this is 0.5, and that looks like 8 and 9, and this will be -3, and that will be -9. Just making up some number, they might not be scaled correctly. So you can see that in this case, the x-intercept, well, I should put x-intercepts, because we have several. We have 1, 2, 3, 4, 5, right? So the x-intercepts are -9, -3, 0.5, 8, and 9. For the y-intercept, we only have 1 right here. This is y-intercept. Let me name this as -1. Okay, so there's y-intercept is located at -1. Okay, so if you want to write it as an order pair, that will be fine as well. But if you put the order pair, for instance, this one will be -9, 0. Make sure you have the y value correctly. Right, so this is just how we graph functions, and of course we are going to learn a little bit more along the semester. This is just an introduction. Don't think we have used this couple minutes just learn everything, right? Okay, so let's take a look at an application. I'm already copied the problems down on the paper just to save some time. You can pause the video and copy it down as well. I'm going to read as problems. When you solve the word problems in math, make sure you understand what kind of information you are given and what information you need to look for, which means what question you need to answer. At the end, when you solve your problem, make sure you go back to check if your answer makes sense or not. Let's take a look at this problem. It says divorce are considerably higher for couples who marry in their teens. The equation models the percentage D. That's something I want to highlight or underline. Percentage D. It seems like this variable D representing the percentage of what? Of marriage that end after n years. Oh, that's another variable, n years. So it seems like n is representing the years if the wife is under 18 at the time of marriage. So the problem is, I did not give you the equation. Let me put the equation in here. So the equation is D equals 4n plus 5. Well, we are going to determine the percentage of marriage ending in divorce after 15 years when the wife is under 18 at the time of marriage. Okay, let's take a look what is given. Again, the given is an equation with modeling the percentage, which is D, of marriage ending an n year. N is the years of marriage if the condition is the wife is under 18 at the time of marriage. The question is asking us to find the percentage. Okay, so which means we are going to find D was given the equation D equal to 4n plus 5, and after 15 years, and n is given as 15. Alright, so in this case, well, I'm going to just substitute n into the equation, so definitely I can find what n is. Substituting in the equation, 4 times 15 plus 5, so that is equal 65. Remember, D is percent, right? So what that meant is the percentage of marriage, right, ending in divorce after 15 years. So which means 65% of marriage ending in divorce after 15 years when the wife is under 18 at the time of marriage. Alright, so these are some of the graphs. We have little taste of that, and in the next several sections we are going to take a look of different kind of graphs, for instance linear, absolute value as we see today, and quadratic functions and polynomial functions. Along the semester we are going to learn the rest of those. Alright, so I'll see you in the next lesson.